So let's go ahead and I'm going to ask you to solve the equation 2 sine squared of x minus cosine of x equals 1. What are some things in this problem do you think are going to make it more complicated than what we did yesterday? Okay, there's a square, and there's two different functions, and there's a 1. So the first thing that I'm going to do is I'm going to say, okay, we need to not have many different functions. There is a trap that people will fall into, because if you take this function right here and subtract 2 sine squared of x from both sides, you end up with minus cosine of x equals 1 minus 2 sine squared of x. And if you look, this right here is actually the identity for what function? Cosine of 2x. Okay, and so people see that and they're like, ah, that was so easy. Now I've got one trig function and it's all smooth skating from here. The short answer to this is yes, it is smooth skating from here if you know what to do with it. But just getting this right here is not generally helpful unless you know that there's a step next that you can use, because right now we actually have two different inputs to cosine. You can't combine them together the way they're written. However, there's three versions of the identity for cosine of 2x, and one of them only involves cosine. Cosine squared of x minus 1. Okay, so one route of solving this is to use the identities like this. So here is a method of rewriting this problem. Generally, when you have squareds like this, that is not the best way to do it. I'm not saying it's wrong, and I just want you to see that you get where you need to be. Okay, it works as long as you are comfortable enough with the identities. Usually, when you have a problem like this, the strategy you want to use is you want to take 2 and remember that sine squared of x is related to cosine squared of x using what identity? The Pythagorean identity, or the Pythagorean identity, however you want to pronounce it. Yeah, well, it depends on where you live. So then 1 minus, so sine squared of x would be 1 minus cosine squared of x using the Pythagorean identity, which I'll just pronounce the way they do in the US. And then minus cosine of x equals 1. And if you look, is this different than this? No, because when I distribute this all out, well, I see that there's a 1 here. I'm going to subtract 1 from both sides, so I'd end up with 1 minus 2 cosine squared of x minus cosine of x. And that's probably not the best way to write this, but I'm on the next page, I'm actually going to rewrite it. Notice that this and this are basically the same. I would just need to move this over here. Okay, so either way you choose to do it, you're going to get to the same spot. But usually this is the safer way because it involves fewer identities and places to make a mistake. If you accidentally use the wrong identity, usually you can wrap your way back. So this is the preferred method. You need to somehow rewrite this so that it's all cosines and it's all cosines of single angles. So the biggest discussion here is this is bad, okay? Because we have two different angles in our trig functions and you don't want to be messing with that. So we needed to convert it back so that they were all the same angle. All right, so remember this line right here. We're going to just start with that. And I'm going to rearrange it on the next page just to put it in our more traditional order of decreasing powers. 1 minus, so it's going to be minus 2 cosine squared of x minus cosine of x plus 1 equals 0. I just moved the 1 so that it was in decreasing power order. The other thing I think I would do personally is we have a leading negative here, and that tends to cause issues for people when they're factoring. And so I think I would just multiply everything by 1. So if I multiply by, I'm sorry, -1. So if I multiply by -1 on both sides, then I'm going to have 2 cosine squared of x plus cosine of x minus 1 equals 0. So I'm going to rewrite this problem. We're really trying to solve this equation. And if it helps to replace the trig functions with variables, by all means do it, because it does avoid some simple mistakes in factoring. And then I'm going to factor this expression so that I'd have two things multiplied together equal to 0, just like in our previous problem. So this is a common strategy with trig equations. Try to break it apart instead of equal to 0. And I'd have 2u and u. That's a positive, so it's going to be +1 and -1. Are you guys okay with that? And if you need to go do the factoring diagonal, so 2 times -1 is -2. That's a 1. Two numbers that multiply to be -2 and add to be 1 would be 2 and -1. And then you can go do your box and figure out, yeah, so do the diamond in the box and figure out what the factoring would be. So then I'm going to solve this now. I have 2u minus 1 equals 0, or u plus 1 equals 0. 2u is equal to 1. U equals -1. So now u is either 1/2 or u is -1. Our original problem involved cosine of x, not u. We had cosine of x because it was u equals 1/2. So cosine of x equals 1/2. And it was u equals -1. So cosine of x equals -1. Now we can actually find out what x is by going to our unit circle. And I need to find the places where cosine of x is 1/2. Cosine depends on x. So there's 1. There's 1. Okay, so there's our two angles. So x could be equal to pi/3, or is that 5 pi/3? Yeah. And then going to cosine of x equals -1, where's the only place that that happens? Pi. Okay, so there's our solutions so far. There is a way to find a pattern in this one, because I don't know if you guys noticed this. If I trace from here to here, and then I trace from here to here, and then I trace from here to here, what do you notice? They're all the same increment of angle. Because of that, you can write the solution to this one very quickly. I could say, well, I know I'm going to start, the first angle is here at pi/3. And then I'd need to figure out how much I add to get to the next one. And I could either do that in my head, or I could just take pi and subtract pi/3 and figure out what the difference between those are. Well, that's like 3 pi/3, oops, minus pi/3, which is 2 pi/3. So that's the amount I need to add each time to get from this angle out to this one, and then from this one to this one, and then from this one back to this one. Yes, so then I'm going to add multiples of that interval. So then I could either put the k, like I could put 2 pi over 3 and then put k right here, or I can just put the k in the numerator, because that's k over 1. And then if I didn't see the pattern, then my answer would look like this. So this is the answer I see a lot of people write for this problem because they don't identify the pattern. And though it is technically correct, it doesn't show full understanding of the problem. The best answer in this particular problem, that would be the best answer. And then this answer down here is technically correct. And k, an element of z, what this means right here, I've used this a lot and I've discussed it a lot, but I'm going to re-emphasize this. This means an integer. Because you can't rotate like half of a full rotation. You have to do a full rotation or 2 rotations or 3 rotations or -2 rotations. You just can't do -1/2 rotations and get to a solution again.